Hello viewers, welcome back to class. I'm super excited to welcome you back to this lesson again. This is Master Builders Online Academy. Don't forget to subscribe to our YouTube channel if you have not done so. And ensure that you turn on the post notification bell. More exciting videos when we uploaded. Guys, ensure that you avoid every unnecessary distractions anytime you are set to watch and to learn new concepts from this platform. And ensure also that you do not skip any part of this video, for this is for your own advantage. And finally, if there be any part in this video you do not understand, when you watch it for the very first time, you have the opportunity to replay the video over and over and over again until you understand the content maximally. Then finally, don't forget to like this video, share this video, and make your necessary comment, where you can ask your question, where you can suggest, and where you can simply appreciate the knowledge or the value you have gained from this video. Now guys, let's get to work. On the board, we are dealing with differentiation of functions. We have lessons before now. So in this lesson, we are going to look at differentiation of direct functions. You can equally call this differentiation of polynomial functions. Alright? Now I type this direct because I'm going to combine other functions alongside with this aspect of differentiation. So that's why I tagged it to be what? Differentiation of direct functions. And what are direct functions? Direct functions are functions where you have the relationship between two or more functions to be either plus or minus, like we have on the board. Now we are asked to what? Differentiate the following functions with respect to x. And like I said before, in objective, you can be asked to find the y over the x, find y prime, find f of s prime, or obtain the first derivative. So in this question, we are going to be looking at the first derivative of each of these functions. And how do we have that done? All we simply do is to put down our solution. Number one, we are told that y is equal to s raised to power c. See, there wasn't y here. You were not given y here. But if you are asked to differentiate this function with respect to x, then automatically it shows that this is what y is equal to this function of x. And that's what we have. So to differentiate this, the y over the x is equal to, very simple. All you need to do is to locate the power of x. Here, the power of x is c. So pull down c. Repeat the base, which is x, put down the power. Then all you simply do is to reduce the power by 1. That's all. And finally, this will have given us 6x. When you reduce 6 by 1, you have 5. This is the answer to this question. Bring down the power and reduce the power by 1. Polynomial function. Then question number 2, we have that y is equal to 5x raised to power 2 plus 4x minus 9. This is what we have. And we are asked to differentiate this. Now we have that the relationship between this is quadratic, this is linear, and this is constant. If you check your standard table of derivative and the type of functions that we mentioned in lesson 2. So this is x squared, x raised to power 1, and this is x raised to power 0. Without x, right? So in this case, when I differentiate this function, all I simply need to do is to break down the power to multiply the existing coefficient. So I will have 5 multiplied by 2, and 5 multiplied by 2 will have given us 10. Then reduce these 2 by 1. Here we are going to be shortening it because we said we are using shortcuts. So if I reduce this by 1, I have 1, which I really do not need, so I can ignore it. When I differentiate 4x, just like I did, when you differentiate ax, x disappears. So you see that the power of x is 1. And anytime you differentiate x raised to the power of 1, the x disappears, leaving only the coefficient. And when we differentiate 4x, guys, we have. Now, minus, when you differentiate constants, we have 0. Because this function is without x. Anytime you differentiate constant, you have 0. So we can simply say minus 0. Then we will ignore this. This is the answer to this question. You see, like I explained earlier, in differentiation or calculus in general, you really do not need the knowledge of general mass. And that's why I mentioned earlier that you may not be good with general mass, but that does not limit you gaining mastery in calculus. You can be very, very sound in calculus without being sound in general mass. So forget the fact that you are not good with general mass. You can be the best in calculus if you follow us as we teach you. It's just step by step. And 1-2 lines, you will have your answers. Okay. Now we have question number 3 on the board. And we equally say y is equal to 8 plus 12x plus 12x squared plus x cubed. So simple as this. So we equally have this as dy over dx is equal to, when you differentiate the first term, which happens to be what? Now we have constant, linear function, quadratic function, and polynomial function. And everything is tagged as polynomial function. Right? Yeah. Now, in this case, what do I do here? All I need to do is to differentiate the individual functions. When I differentiate constant, I have 0. I can boldly ignore it. But if you don't want to ignore it, you can put it down. But don't forget that this is objective. So just ignore it and get your answer straight. When I differentiate 12x, being that the power of x is 1 here, x disappears, I will be left with 12. When you differentiate this quadratic, the power 2, identify the power which is 2. 2 will multiply the existing coefficient, which would have been what? 12 multiplied by 2. And 12 multiplied by 2 will have given us what? 24. We have plus 24. Then x, reduce this power by 1. We are going to have s raised to the power of 1. Then you ignore it. Then plus, when you differentiate x raised to the power of 3, all you just need to do is to bring down the power, put down the base, then reduce 3 by 1. You are going to have 2. Don't forget, anytime you differentiate a polynomial function, the original power must reduce by 1. Question number 4. In question number 4, we have y is equal to 3 plus x squared over 2 plus x cubed over 6 plus x4 over 24. Now guys, listen carefully. There is a difference between this fraction that we have here and when we have 6 over s cubed. So I want to quickly explain something here. This guy is different from this, right? Now in this first guy, we have that the numerators are the functions of x. So anytime you have the numerators as the function of x and the denominator as constants, it means that you are dealing with polynomial functions. Because understand that 1x squared over 2 is the same thing as 1 over 2x squared. So this is the coefficient. Is that taken? This is it. So this is a linear function or polynomial function. So this is different from a case where you have the numerator to be a constant and the denominator to be a function of x. So when you have the numerator as a constant and the denominator as a function of x, then you are dealing with inverse functions. Are you there? So if this is understood, therefore dy over dx would have been equal to, now we are going to differentiate these functions individually. First we have a constant, we have a linear function, we have quadratic function, we have the rest as polynomial functions. Now if that is understood, if we differentiate 3, which is a constant, we know that we have 0. Anytime you differentiate a constant, then we will ignore that 10. When you differentiate x raised to the power of 1, you have the coefficient left. And now the coefficient of x here is 1. Then you put down 1. Then plus, when you differentiate this x squared, the power of x will come down and become the coefficient of x. So we have this as 2x. When we reduce 2 by 1, we have 1 all over 2. Then plus, when we differentiate x raised to the power of 3, we bring down 3. Then reduce 3, which is the whole power, by 1. Then we have x raised to the power of 2 all over 6. Then plus, when we differentiate x raised to power 4, we will bring down 4. Then pull down, reduce 4 by 1, we have these are 3 all over 24. Now, the next thing we quickly do is to find out if we can reduce this equation. Of course, it is possible to reduce this equation that we have here. Now, final answer would have given us 1. 2 takes care of 2. We are left with x and the second term. Then the third term, 3 is a factor of 6. Therefore, 3 into itself is 1. And 6 divided by 3, we have 2. Then also, 4 is a factor of 24. Therefore, 24 divided by 4 is 6. This will have given us x raised to the power 3 all over 6. This is the answer to this question number 4. Guys, you see how simple it is. And that's what I mentioned earlier, that when you understand principles, you become principal. And if you understand boundary conditions, you will not overstep your boundaries. Right? Now, question number 5, we have y as a function of 3x raised to the power of 4 plus exponent x plus sine x. This is what we have here. Very simple. Very, very simple. All you need to do is to identify the functions that are here. And you see the reason why I said this is called direct function, because it can be a combination of different functions, but the relationship between these functions will either be what? Negative sign or positive sign. Not multiplication, not division, and not exponent. Are we there? Now, all we need to do is to differentiate these functions individually. So, first function I have here is polynomial function, and anytime you differentiate polynomial function, you bring down the power to multiply the existing coefficient, and we are going to have 4 multiplied by 3. And 4 multiplied by 3, we have this as 12. And then we reduce the power by 1. If we remove 1 from 4, we will have this as 3. Plus, understand that when you the next term of function is what? An exponential function. And when you differentiate exponential x, you equally have exponential x. And when you differentiate sine x, which happens to be trig function, you have this as constant. So guys, this is the answer to these very questions or problems that we have on the board. Now listen carefully. These problems we just solved together are not enough to make you gain mastery over this aspect of differentiation. So I urge you to visit your textbook or go online, your Google, and search for more problems, solve more problems, so that you will gain mastery. But I bet you that the little problems we solve there will give you all the idea that you need to solve hundreds of problems on your own. If you have questions, document it at the comment section. And if you have not subscribed to this YouTube channel, do consider subscribing to this YouTube channel and ensure that you turn on the post notification bell for more exciting videos. Guys, very quickly, you can check the description below where you will find the link to the next lesson. See you guys in the next video.